Good morning, children. Today I am going to teach nomenclature of alkanes. This is in continuation with the previous session. So in this session I am going to teach how saturated hydrocarbons are named. So alkanes are nothing but saturated hydrocarbons. Means these hydrocarbons are made up of hydrogen, carbon and with single bonds. So in the case of alkanes, no multiple bonds are found. Multiple bonds means double and triple bonds. Right? So that's about alkanes. Alkanes are saturated hydrocarbons whose composition is according to the general molecular formula or general formula, that is CnH2n plus 2. N stands for number of carbon atoms, 2n plus 2 stands for number of hydrogen atoms. Fine. That's about alkanes. Now how these alkanes are named? These alkanes are named based on the substituents corrected, right? Based on the length of the hydrocarbon, based on the repetition of alkyl groups, based on how these substituents are arranged, on what basis, whether they are arranged on alphabetical order or not. All these things I am going to teach in this session. So this is divided into three parts. This is nomenclature of alkanes. First one is straight chain hydrocarbon. Number 2, branched chain. Or branched part. Number 3, cyclic compound. Means whenever a particular organic compound is given to us, we have to trace or identify the straight chain hydrocarbon. Number 2, after identifying the straight chain hydrocarbon, we have to see whether that straight chain has branch or not. If branch is there, whether if the branch more than 2 or more than 1 branches are there, then we have to find out how many branches connected to it. These branches are nothing but substituents. In previous class we had seen the functional group and the substituent connected to the straight chain. So when more than one substituent or branch is connected, we have to find out or identify how many of them are similar. Right? Next, in common system, how do we give the name to such substituents? And finally, cyclic compounds. Those compounds are those hydrocarbons which have cyclic structures. So with that, nomenclature of alkanes will come to end. Now let us see the first part of nomenclature of alkanes, that is straight chain hydrocarbons. Number 1. Straight chain hydrocarbons. This title itself is informative. in the given organic compound or alkane, there must be what you call straight chain, long chain or straight chain. Right? Now let us see one example. There can be branches also. Straight chain will be there and the branches connected to it will also be there in the hydrocarbon. Right? When there are no branches, when there is only one straight chain, how should it be named? Let us see example 1. Hydrocarbon which contains only one carbon atom is called methane. Meth means 1. Second member is ethane. ETH. Eth means 2. Third member is butane. Propane. Pro means 3. N means that is the suffix of alkane, which shows that the given compound alkane that is saturated. Okay. Next fourth member is butane. So in chemistry, but, B-U-T, we have to read it as but. English B-U-T is different, that is but. Right? In chemistry, but means 4. So this is what we need to remember. Meth 1, eth 2, pro 3, but 4. After that, penta, hexa, hepta, octa, nona or non, dec or deca. These you have come across. These terms are familiar to you because you have come across these terms in mathematics. Penta means 5, hexa means 6, octa 8, deca 10, dudeca, D-O-D-E-C-A. Dudeca means 12. In chemistry, do means 2. Dec or deca means 10. Dudeca means 2 plus 10, 12. Fine. Now let us see an example for straight chain which doesn't have any branch. It is butane. Name of this compound is butane. As I told you earlier, but means 4. Now, example 2. Now, in this compound, we have altogether 6 carbon atoms. There is no branch. It is a straight chain compound. Right? Now, we have 6 carbon atoms in this compound, therefore it is called hexane. Like that, decane, one which contains 10 carbon atoms, right? CH3, CH2, 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 one, two, three, 4, 5, 6, 7, 8. So 9 carbon atoms we have in this structure. 1, 2, 3, 4, 5, 6, 7, 8, 9. So its name is nonane. And these structures do not have any branch. Right? That's about straight chain hydrocarbons. After this, we will move to the second part where we are going to see both straight chain as well as the branch or the substituent connected to one of the carbon atoms or more than one carbon atom of the straight chain. Here one thing you need to remember, in all these structures you can see tetravalency of carbons, right? Tetravalency of carbon should not be changed. It should not be damaged. Right? So that's about straight chain hydrocarbons. Now, let us see the second part, that is branched chain hydrocarbon. Branched part or branched chain hydrocarbon. Branched chain hydrocarbon. As I told you, branch can be any substituent. To understand this, let us see one example. This is called carbon skeleton because hydrogen atoms are not there. Okay. Imagine to this carbon atom one alkyl group is connected. Right? To the other carbon atom, other alkyl group is connected. Both are alkyl groups. Right? Now, to satisfy the valency, we will add hydrogen atoms, keeping valency of carbon as 4 in the mind. Next one. Now, in this compound, these two are called branches. And that too they are substituents, and these substituents are nothing but branches. Why these substituents are called branches, or why these branches are called substituents, is from these carbon atoms to which these alkyl groups are connected, from them hydrogen atoms are substituted by methyl and ethyl groups. That's why they are said to be substituents, right? And here these substituents are nothing but the branches. Next, this part is called straight chain or long chain. So in this compound we have two parts. One is straight chain. Number two, substituents. That is methyl and ethyl. Two substituents. Now the question is, if the substituent, that is alkyl group, here both are alkyl groups, methyl and ethyl, and these substituents may have branches in them in turn. So when they have branches in turn, in common system, how they are named, let us see. So when alkyl group has branches, how is that alkyl group named in trivial system or common system? Let us see. Imagine two carbon atoms are connected to one carbon atom. That is hydrocarbon only. It is like this. This is one carbon atom. To this, two other carbon atoms are connected. Right? 1, 2, 3, 4. So what I will do is, I put only one carbon atom and here one bond. This bond stands for connection, linkage. Right? So there is something which is connected here, that is the meaning. Now, if you look at this carbon atom, it's valency. 1, 2, in between carbon and hydrogen, one bond. 3, and this is 4. So valency of this carbon is satisfied. So in that way, whenever two carbon atoms are connected to one carbon atom, or whenever two similar alkyl groups, that to two methyl groups, are connected to one carbon atom, we have to give the name to that as iso. Iso means similar. What is similar here? Two alkyl groups are similar, that are connected to this carbon atom. Right? So, altogether we have three carbon atoms in this alkyl group. So, three carbon atoms present in the alkyl group is called propyl. If alkyl group has only one carbon atom, methyl. If alkyl group has four carbon atoms, butyl. If alkyl group has five carbon atoms, pentyl. So, in that way, this is containing three carbon atoms, so its name is isopropyl. Next, in this example also, there are two alkyl groups connected to one carbon atom. Right? But here 1, 2, 3, 4, 2, 4. Yeah. Now in this case, two alkyl groups are connected to one carbon atom. Right? So it is iso. Prefix we need to write iso. Number 2. Altogether four carbon atoms are there. So it is butyl. But means four, already I taught this. Butyl refers to alkyl group containing four carbon atoms. Next. If two alkyl groups are different types are connected to one carbon atom. Look at this. In this way. Two alkyl groups. This is one alkyl group, this is other alkyl group. Alkyl group containing single carbon atom is methyl. And this is ethyl. Right? And this is, yeah. Now, we have two different alkyl groups connected to one carbon atom, so its name should have the prefix secondary. Secondary can be abbreviated by SSC. And altogether we have 2, 3, 4, 5 carbon atoms. So it is secondary pentyl. Right, children? Yes, children. Now we are going to see third type of alkyl group, wherein 3 carbon atoms are connected to 1 carbon atom, or 3 methyl groups or 3 alkyl groups, and each alkyl group is equal to methyl to 1 carbon atom when 3 methyl groups are connected. Let us see its name in trivial system with example. So this is 1 carbon atom. To this 3 carbon atoms are connected in this way. This is a linkage, right? Now this is completely only 1 alkyl group, and in this case, since 3 alkyl groups are connected to 1 carbon atom, so it should be named as tertiary. T-E-R. Ter means 3. Tris, T-R-I-S. Tri, all this means 3. So here we have 3 alkyl groups connected to single carbon atom. So this is tertiary. That can be abbreviated by T-E-R. T-E-R, T-I-A-R-Y. Tertiary. And altogether we have 4 carbon atoms. Right? So butyl. Tertiary butyl. This is 1 alkyl group. Next. Imagine to 1 carbon atom, 4 other carbon atoms are connected. Right? They are like this. Now, this compound, see 4 carbon atoms are connected to this carbon atom, but out of those 4 carbon atoms or 4 groups, 3 groups are similar. 4th one is different. This is also actually methyl, CH3. From that one carbon atom is removed, that's why we got this bond. Okay, so such an alkyl group is said to be neo. And altogether we have 5 carbon atoms in this, so this is neo pentyl. Neo pentyl. So that's about some of the alkyl groups which are slightly complex or which are branched. Methyl CH3, ethyl, propyl, butane. These are not the complex alkyl groups. But iso, secondary, tertiary, neo, these are slightly complex alkyl groups. So in common system they are named in that way. Yes, children. Now we are going to see how the branched chain alkanes are named. So nomenclature of branched chain alkanes. To understand nomenclature of branched chain alkanes, we have to identify or we have to follow certain rules. Like number 1, long chain hydrocarbon part or long chain rule. Number 2, least sum rule or lowest sum rule. Lowest sum rule. Number 3, use of di, tri, tetra prefixes. And last one is alphabetical order or substituents. So first one is straight chain. Hydrocarbon. Next, lowest sum rule. Number 3, use of di, tri, tetra prefixes. Number 4, alphabetical order. So these are the 4 rules. Now let us see these rules one by one. First one is straight chain hydrocarbon. Straight chain or longest chain and long chain. Hydrocarbon. Imagine an hydrocarbon of this type 3, 4, 7, 8, 9, right? And here we have one substituent CH3 and here we have a substituent CH2, CH3. This CH2, CH3 can be written as C2H5. Now to satisfy the valency of each carbon atom, we will add hydrogen atoms. So, now in this compound, this part is straight chain or long chain hydrocarbon part. Long chain hydrocarbon. Okay, and these two are branches or substituents. Right? So that's how the long chain of the given compound is identified. That may have any number of carbon atoms in it. And number 2, second rule is lowest sum rule. Lowest sum rule. In this case, what we are going to do is, I am going to take same example to make you clear. Right? That is 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon atoms. And here one methyl group, and here one ethyl group. And we will add hydrogen atoms. To satisfy valency of each carbon atom. Yeah. Now, once the structure of this type is given to us, or when the name is given, we will draw the structure. But all these things should be clear. Then only it is possible to draw the structure when name is given, or it is possible to write the name when structure is given. Now, I will give numbers in 2 ways. Left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Next, I'll give numbers from right to left. 1, 2, 3, 4, 5, 6, 7, 8, and this is 9th carbon. What lowest sum rule states or tells us is whenever two substituents are connected to two different carbon atoms of the long chain, their positions should be identified. Positions means the number of carbon atoms to which those substituents are connected. Now, see, in one case, in the same compound, case 1, I have given numbers from left to right. Altogether 9 carbon atoms are there and positions of these branches are 2 and 6. Right? When numbers are given left to right, the sum of the positions of the carbon atoms to which these substituents are connected is 2 and 6. So that is equal to 8. Now, if we move to second case, wherein in the same compound, case 2, wherein we have given numbers from right to left, then position of this ethyl group is 4. Right? So this is right to left. It is 4 plus position of this methyl group is 8. So 4 plus 8, that is equal to 12. So what lowest sum rule states is sum, SUM, addition, adding. What this rule says is whenever numbering is done in two directions, provided there must be more than one substituent, then we have to take sum of positions of those substituents in both the directions, left to right, right to left. When we come to know the sum, sum, then we have to compare which is lower than the other. So here 8 is less than 12. Therefore, giving numbers from left to right is correct, but not right to left. That is what lowest sum rule states. According to this rule, numbering is done in the case of alkane containing more than one substituent. Right? When numbering is done in two ways, left to right and right to left. In both the ways, we have to find out sum, SUM, and we have to compare which one is less than the other. Here we have calculated sum of positions of the substituents left to right, which is equal to 8, and right to left, that is equal to 12. Right? Since 8 is less than 12, therefore giving numbers from left to right is correct. Therefore, this sum is correct. That is giving numbers from left to right. So that's about lowest sum rule. Now we are moving to third part, of nomenclature or branch chain alkanes, that is use of di, tri and tetra prefixes. We will see two examples, where in one example two similar alkyl groups are there. In second example we have two similar alkyl groups, besides that one different alkyl group. Now look at this carbon chain, wherein we have 6 carbon atoms. To second carbon atom, left to right, if we count, this will be the second. Methyl group is connected, right? And to third carbon atom, ethyl group is connected. Ethyl group directly you can write C2H5 also, instead of writing CH2, CH3. And these alkyl groups can be shown above carbon atoms also. Now to satisfy the valency, I am adding hydrogen atoms. Now, if we give numbers 1, 2, 3, 4, 5, 6. See, long chain hydrocarbon is there and branches are also there. Now, name of this compound, how should it be written? Let us see. The third carbon atom ethyl group is there, so we write 3-ethyl. Why should we write first ethyl? Why not methyl? That will come in fourth part. Okay. Right now, just you see the name what I am going to write, whether it matches with the structure of the compound or not. So 3-ethyl, 2-methyl, and altogether 6 carbon atoms are there. So it is hexane. Now let us see example 2. 4, 5, 6. And here the second carbon atom I am adding 2 methyl groups. Third carbon atom as usual ethyl group. Now hydrogen atoms I add by keeping valency of each carbon atom in the mind. 1, 2, 3, 4, 5, 6. And name of this compound, let us see. Here 2 methyl groups are similar, right? If we want, we can add one more methyl group anyway, right? Now name of this compound is 3-ethyl. The second carbon atom 2 methyl groups are connected, therefore 2,2-dimethyl hexane, right? So this is one example. We will see third example where we can use the prefix tri. This is example 3. To second carbon atom on methyl group, to the same carbon atom on non-methyl group, and here ethyl group and here one methyl group. Now I will add hydrogen atoms. Now this is that compound. So numbering you can give in both the directions, and you will come to know in which direction the numbers given is correct. So here 1, 2, 3, 4, 5, 6, 7. right? And in this case, see, ethyl group position is 3. So 3 ethyl. Now 3 methyl groups are there. Positions are 2 and 5. So 2, 2, 5, trimethyl heptane. So in that way, the prefixes di and tri are used. Now let us see the last part, that is alphabetical order of substituents. Alphabetical order of substituents. This is the last part. We have many substituents like methyl, ethyl. First letter of each alkyl group we have to take into account, right? One which is going to receive. First one. Receive means coming after. So preceding one, first one. Yes, children. If you take butyl and propyl, in butyl first letter is B, propyl first letter P. So butyl name should be written first, thereafter propyl. Next, if ethyl and methyl are there, ethyl first letter E, methyl first letter M. E comes first, right? Thereafter M. So the name ethyl should be written first, thereafter methyl. The previous example, second example of use of di, tri, tetra prefixes. You recall that only I am going to write here. Three, 4, 5, 6, 7. Yeah. To second carbon atom, I am adding methyl group. Right. To third carbon atom, ethyl group, and then to fifth carbon atom, methyl group, again to the second carbon atom, methyl group only. Now, if I give numbers 1, 2, 3, 4, 5, 6, 7. Now, see the substituents 1, 2, 3, 4. 4 substituents are there. Among them, 3 substituents are same. Right? And 4th substituent is ethyl. So, according to alphabetical order, ethyl name will come first because first letter of ethyl is E. First letter of methyl groups is M. So, name of this compound will begin with 3 ethyl. Now, methyl groups positions 2 and 5. At 2 means second carbon atom, 2 methyl groups are there. At 5th carbon atom, we have only 1 methyl group. So, we can write 3 ethyl, 2, 2, 5, trimethyl. Now, long chain has 7 carbon atoms. 1, 2, 3, 4, 5, 6, 7. So it is derivative of alkane, heptane. The alkane is heptane. So 3-ethyl 2,2,5 trimethyl heptane. Then now we give names. Right, children? So alphabetical order refers to the first letter of the alkyl groups. That's about alphabetical order of substituents. In that way, the given saturated hydrocarbon is named. Thank you, children.